How to generate high-quality CFD meshes for complex designs. Are you curious about how to create high-quality computational fluid dynamics meshes for complex designs? Let's break down the process step by step to ensure you can achieve the best results. First, understanding the geometry and flow features of your design is essential. Identify the areas where flow changes, turbulence, or boundary layers occur. These regions need a finer mesh to capture the physics accurately. Next, consider simplifying the geometry where possible. Removing unnecessary details that do not significantly affect flow can make the meshing process easier and improve overall mesh quality. This simplification also helps in reducing the computational resources needed. When it comes to choosing mesh types, structured meshes are great for simpler geometries. They provide higher accuracy and efficiency. For more complex shapes, unstructured meshes work better. You can even combine both types in a hybrid mesh to get the best of both worlds. Advanced techniques like advancing front or Delaunay triangulation can help create quality meshes in challenging domains. Refining the mesh in critical areas is another important step. Focus on regions with high gradients, such as near walls or sharp corners. Implementing boundary layer meshing near walls is vital for accurately resolving velocity and thermal gradients. Adaptive meshing is a powerful tool that dynamically refines the mesh during simulation based on the solution gradients. This method improves accuracy without adding too many elements. Once you have your mesh, verify its quality. Check parameters like aspect ratio, skewness, orthogonality, and smoothness. Poor quality elements can lead to numerical instability and inaccurate results. Aim for low skewness and aspect ratios close to 1. A mesh-independent study is also necessary. Run simulations with progressively finer meshes to ensure that your results are consistent and not dependent on mesh size. This confirms that your mesh resolution is sufficient for accurate results. Utilizing advanced meshing software tools can greatly streamline your workflow. Tools like ANSYS meshing, OpenFOAM SnappyHex Mesh, or GMSH offer automation and quality control features that can make meshing complex designs much easier. While finer meshes improve accuracy, they also increase computational time and resource requirements. Strive for a balance by refining only where it is truly necessary. Lastly, automating and standardizing your meshing process can reduce human error and ensure consistent quality across your models. For mechanical engineers tackling complex computational fluid dynamics simulations, following these steps will lead to reliable and accurate results. For example, in turbine blade cooling simulations, using fine boundary layer meshes along with adaptive refinement around trailing edges can capture essential flow features without excessive computational costs. By implementing these strategies, you can effectively generate high-quality computational fluid dynamics meshes for your complex designs, ensuring that your simulations yield accurate and reliable results.